So today we're going to focus on word problems related to systems of equations. So you're going to be required to complete your word problems using this four-step plan. So when you define your variables, it can be one of a couple of things. So you could either define your variables with just a plain let statement. So let, x equal the number of rabbits and y equal the number of cats. Now, I don't know what it is. Or you can put in a picture, or you could have a table that's organizing all of your information. So one of those three things. Then you're going to create and pull out of the problem your equations. And so in this case, you're going to have two equations with two unknowns. Then you're going to solve your equations above here. So we typically write the equations and solve down. And then you have to write the answer in a full and complete sentence. So this should be in a full and complete, it's actually two E's, sentence. So we typically will use the word therefore or a triangle of dots. Therefore, the capital of Bogota is, I have no idea, but there's your complete sentence. Or, therefore, the number of rabbits is 15 and the number of cats is 10. So there should not be, therefore, x equals 6. I don't know what x is. Equal signs do not belong in a sentence, that kind of thing. So here we go. We're going to go through a bunch of word problems. You can always pause the video if you need to write stuff down, that type of stuff. So here we go. So for example 1, I'm going to move this up, make it just a smidge bigger. For this example, I'm going to do several different types of let statements on various problems. So for this one, let's get our four-step plan in here. You're going to read the problem first. Then you should highlight things that stand out to you. So this is a fairly simple problem. I typically will go straight to the question to see what it is I don't know. That's typically how we define our variables. So I'm trying to find the two numbers. So clearly I must not know my numbers. So that's what our let statement is going to be. So we are going to let x equal the first number. Actually, I'm going to use a pound symbol. This is not a hashtag, it's a pound symbol. All right, and then y is going to equal my second number. Then we need to look to see what our equation to solve is. So start looking to highlight some stuff. So the first sentence says the sum of the two numbers is 30. So my two numbers are x and y. So their sum, x plus y, must equal 30. Then the next thing says their difference is 6. So if I subtract my numbers, because that's what the difference is, then their difference must equal 6. So now we have taken the words out of the word problem and we just have an algebra problem to do. So from this point, you're going to solve a system with two unknowns. And if I add the system exactly as you see, my y's cancel out. So at this point, pause the video. I want you to try to solve the system on your own and then restart the video. Okay, so hopefully you were successful with that. Now, x plus x is 2x's. And 30 plus 6 is 36. Divide by 2. And then x is equal to 18. Then we need to find y. So we're going to plug in 8. We're going to plug into one of our original equations up here. I personally like this first one. So instead of x, I'm going to put in 18 plus y is equal to 30. If I subtract 18 from both sides, y would have to be 12. So here are my two solutions. So now I'm ready to write my therefore statement. So the question says, find the two numbers. So you're going to answer this question as a complete sentence statement. Therefore, the two numbers are. So therefore, you can use ... uh, 12 and 18. And no, you cannot use an and symbol. So, and I have a period at the end of my sentence. So it's that easy. So that's a pretty simple problem. You're not allowed to guess and check. If you guess and check, you will lose all points for here, and this carries the most weight in a word problem. Let's look at the next one. So in this example, okay, we have the cost to a movie is $8 for an adult ticket and $6 for a child's ticket. If 70 tickets were sold for a total amount of $520, how many of each type of ticket was sold? So I need to find the number of types of tickets sold. So for this one, I like to make a table of values. Anytime I have something that I'm going to multiply by a value to get a total value, I like to make a table of values. So this is one of the options for a let statement. Okay, so I have a choice of adult tickets, or child tickets. Okay, then across the top, if I knew the number of tickets that I had, and if I knew how much they were, so times their value, I would multiply them together to get the total value of those tickets. So as I'm standing at a ticket counter and I say I want to purchase 10 tickets, they're going to take those 10 tickets, the number of tickets, and multiply it by the price of those tickets to get the total cost. So then I need to fill in my chart. So as I read my table, table or problem, something, I want to start highlighting some important stuff. So the cost to a movie is $8 for an adult ticket and $6 for a child's ticket. So I don't know how many tickets I have, but I do know. So I'm going to let A equal my number of adult tickets because I don't know that, and I'm going to let C be my number of child tickets. I do know that the value of an adult ticket is $8 and the value of a child's ticket is $6. Then as I keep reading, if 70 tickets were sold for a total amount of $520, how many tickets of each type were sold? So typically, when I have totals, I'm going to put a total down here at the bottom and a total down here at the bottom because they're telling me that we know the total number of tickets. Well, I don't know how many is adult and child, but I know that in total I have 70 tickets. So I'm going to put here at the bottom 70. Well, you can't even read that. I'm going to put that in red, 70. And then I know that the total value, the cost of all 70 of those tickets is going to be $520. Now, typically, this column here, you typically calculate. So 9 times out of 10, you got to calculate these boxes in here, and it tells you right up here how to calculate it. This times this is going to equal this. So A times 8 is going to be 8A. We don't write things as A8. And then C times 6 is going to be 6C. And then what's so great about this table of values is that this column right here will typically be one of your equations to solve, and this column right here will be your other equation to solve. So as you can see, the number of adult tickets plus plus the number of child tickets will equal 70. So that's one of my equations to solve. So A plus C is equal to 70. And then 8A plus 6C should give me my $520. So 8A plus 6C is equal to 520. So at this point, I want you to stop the video and I want you to solve that system on your own. Decide which equation or which variable you're going to eliminate and solve. All right, so hopefully you have solved your equation by now and figured out what your answer is. So I'm going to finish going through this. So I've decided that I am going to eliminate my C's. So I am going to multiply this equation by -6. So I end up with -6A minus 6C equals -420. And then I have 8A plus 6C equals 520. And then I'm going to add those together. My C's cancel, and I get 2A is equal to 100. Divide by 2. And then I get A is equal to 50. Now, if A is equal to 50 plus some amount, C is 70, wouldn't C have to be 20? 50 plus 20 is 70. So I know that C has to be 20. And so does that answer the question of how many of each type of ticket was sold? So therefore, ... there were 50 adult tickets, 50 adult and 20 child tickets sold. Let's look at a different one. All right, so let me make this one bigger. All right, so this one is a geometry problem. So again, with a geometry problem, and I know it's a geometry because it's talking about perimeter and a rectangle. So your let statement can be a picture, and a picture is worth 1,000 words. So let's see what we're going to draw. It says the perimeter of a rectangle is 32 meters. So that's kind of important. I'm going to highlight that. Then it goes on to say that the length is 2 less than twice the width. Find the dimensions. Okay, well, let's draw a picture of what we're looking at. So a rectangle, oops, that would be completely the wrong thing of what I was looking for. So a rectangle is a 4-sided figure. The question says find the dimensions of the rectangle. That would be its length and its width. Well, I don't know the length and I don't know the width. So we're going to identify that. This is going to be our let statement. So let's see what else they tell us. They said, let's get out my laser pointer. Love my laser pointer. So they said that the perimeter of the rectangle is 32 meters. So perimeter means to add up all the sides, right? So I'm going to add up all the sides, and they should come out to be 32. So aren't there 2 widths and 2 lengths? So that means for our perimeter, I've got 2 widths plus 2 lengths should come out to be 32. And so I got that from, oh, look at that's fascinating. So I got that from, don't mind me, I'm getting distracted by my highlighting. So I got that from here. So let me rewrite over that in black and see if it'll let me. Oh yeah, there we go. Okay, then the next one we're going to get is from our highlighted blue area. So I'm going to put the highlighted blue area here. And it says the length is 2 less than twice the width. Well, that's kind of getting a little garbled, so I highly suggest that you look for the word that means equals. And if you recall, the word is means equals in mathematics. So I'm going to put in equals right here. There's my equal sign. That's an equal sign. So it says the length equals. So the length is clearly just L. So we're going to put L equals. Then it says 2 less than twice the width. Well, this is a key phrase, less than. Kids mess up on this phrase less than all the time. It does mean subtraction. So what you want to look at is what comes before the phrase less than and what comes after. So we have 2 coming before and twice the width coming after. So twice the width would be 2w and then 2. So the question is, it's either 2 minus 2w or 2w minus 2. Anytime you have the phrase less than, you have to flip these. So it's going to be 2w minus 2. So we got to flip it. And now I want you to pause the video and solve this system on your own. You could use substitution, and you could take this value and sub it in for L, or you could move the 2w over to the left by subtracting it, lining up your w's, lining up your l's, and then eliminating something. So you make the choice. Okay, so I'm going to use substitution just to be different. And so I'm going to sub in L for there. So I have 2w plus 2 times the length, which is 2w minus 2, equals 32. So then I'm going to distribute the 2. I apologize if you can hear Miss Ray across the hall. She's really loud today. So 2w plus 4w minus 4 equals 32. Collect your like terms. Those give you 6w minus 4 equals 32. Then I want to get that by itself, so I'm going to add 4. And I end up with 6w equals 36. Divide by 6. And you get w equals 6. So now that I know the width is 6, then I can take this and substitute it back into here to get my length. So that's what I'm going to do. I am going to take length equals 2 times 6 and then subtract 2. Well, 2 times 6 is 12, minus 2 is 10. So L is equal to 10. So now I have found my dimensions of the rectangle, so therefore the dimensions are length and width. 6 meters, because that's my unit of measure in the problem, by, can't use a little x, 10 meters. And that's it. Let's look at example 4. All right, so in example 4, we have the sum of two numbers is 7. There's that phrase again, less than twice the largest number. The difference is 2 less than the smallest number. Find the numbers. So I don't know the numbers, but I do know that one is larger than the other. So I'm going to let x equal the smaller number and y equals the larger number. Then let's read our problem. And we have the sum of two numbers is 7 less than twice the largest number. So we're going to use that to write our first equation. So again, our equals to is where the word is. So there, and I've clearly got the wrong, there. So I need my equals. So here's my equals. So the sum of two numbers, that must be x plus y. Is equals, and then we have this phrase less than, 7's coming in front, twice the larger is coming behind. Well, if the larger number is y, then I've got 2 times y. And then if 7 comes in front and I have to flip these, it's going to be 2y minus 7. So there's my first equation. We'll deal with that in a minute. Then your second equation is the difference is 2 less than the smallest number. So again, I want to find my is. So there's my is. So that's my equals right there. The difference, so I'm going to take the two numbers. I typically like to take the larger number and subtract the smaller if I'm doing a difference. So there's my equals. And then 2 less than, so again I have that phrase less than, 2 comes in front, the smallest comes behind, so the smaller in this case I have made x, so it's going to be x minus 2. So then you have to decide if you're going to use substitution or elimination. I think I'm going to eliminate, so I'm going to get all of my x's over here and my y's, and all my constants are going to be over here. So for the first equation, I want to move my y by subtracting it, 2y, from both sides. So I'm going to get x, a positive y and a negative 2y is a negative y, equals, those are going to cancel, a negative 7. Then for the second equation, I want to move my x, so I'm going to subtract x. I want my x's to come first, so a negative x and a negative x is a negative 2x, and then a positive y equals, and then I have a negative 2 left over there. So that's my system. When I add this system together, those y's are going to cancel. I have a positive x and a negative 2x, gives me a negative 1x equals negative 7 and negative 2 is negative 9. Divide by negative 1, and I get x is equal to 9. So there's 1. Then you're going to have to plug this back in to one of these two. I'm probably going to plug it into the first one. So instead of x, I'm going to put in a 9, and then plus y equals 2y minus 7. So you want to collect your y's. So I'm going to subtract y. So I get 9 on the left, 2y minus y is y, minus 7, and then add 7 to solve for y. And so you get 16 is equal to y. So your two numbers are 9 and 16. So therefore, the numbers are 9 and 16. All right, so with example 5, it gets slightly more complicated. It says the senior, let me get a different pointer. How about, here, let's try this. So the senior class at High School A and High School B planned separate trips to New York City. The senior class at High School A rented and filled 13 vans and 14 buses with 604 students. High School B rented and filled 7 vans and 14 buses with 532 students. Every van had the same number of students in it as did the buses. What they mean by that is there might have been 12 kids in a van and 60 kids in a bus. So vans and buses don't carry the same amount of kids, but each van carries the same amount, each bus carries the same amount. So our job is to find the number of students that would be in a van and the number of students in a bus. So let's set up a 4-step plan. So since we're trying to find the number of students in each van and bus, I am going to let V equal number of students in van, and B equal number of students in a bus. So then we need to set up an equation to solve. So if you think about it, we know some totals here. We know that high school A had 604 students go. Some were in vans and some were in buses. We know we had 13 vans and 14 buses. Sorry, that's my daughter's dog. Somebody clearly has come home. Stop, Joe. And Jojo feels she has to bark too. All right, so if I know how many kids were in a van, I could multiply that by 13 to get the total number of kids in all the vans. And if I knew how many kids could be on the buses, I could multiply that by 14 and then add them together to get to that 604. Since we don't know them, we're going to use V and B. So our first equation to solve for high school A is going to be 13 times V as in Victor plus 14 times B as in boy equals 604. So then that means that for high school B, since they have 7 vans, we will have 7V plus 14B for buses equals 532. So now you need to stop the video and solve this system and decide whether you're going to eliminate the V's or eliminate the B's and solve. So pause the video and solve. Okay, so hopefully you have solved your system. Since the B's both have 14 as a coefficient, I'm going to go ahead and eliminate my B's. So you're going to have to multiply one of the equations by -1. So I've decided to multiply the second equation by -1. So I haven't touched the first. And then if I distribute the negative all the way through to the second, I have negative 7V minus 14B is equal to negative 532. So now, if I add the two equations together, the B's are going to cancel. And then 13 minus 7 is 6V. And then if I subtract 2 from 4, I get 2. And then I'm going to borrow 1 from 6. Add it to the 10. So 10 minus 3 is 7. And so I get 6V, that's not a B, that's a 6V is equal to 72. So then I'm going to divide both sides by 6. And the number of students in a van is going to be 12. So now I need to sub this into one of the original two equations. I like the second equation because it's smaller numbers. So I'm going to use that second equation. And I have 7, and instead of V, we're putting in 12. Then plus 14B equals 532. So then 7 times 12 is 84, plus 14B is equal to 532. To solve for B, I've got to get this by itself. So we are going to subtract 84. So I get 14B is equal to, so then I'm going to borrow 1 from the 3, and 12 minus 4 is 8, and then I am going to borrow 1 from the 5, 12 minus 8 is 4, and then I get 4, so 448. And then we're going to divide by 14. And I get B is equal to, I think 3 times. So 3 times 14 is 42. So that leaves 2 left to go with the 8, and 14 goes into 28 twice. So we must have 32 kids on the bus. So now we have figured out the number of students in each van and bus. So therefore, there are 12 students in each van and 32 students in each bus. Now you always need to look at your answers to see if they're reasonable. And so it would be unreasonable if my answers here had been decimals or fractions, because you can't have partial people, or if they had been negative, because you're not going to have a number of people. And I would expect that there would be more students in a bus than there is in a van. So it's very reasonable. Let's look at our very last question. All right, so example 6. I would title this Wind or Current Problems. So it doesn't matter whether we're talking about wind or current. If we are flying with the wind, or if they say there's a headwind, then that means that we are going against the wind and the wind is slowing us down. If we are flying, if we're flying with the wind, I just said that. I think I said that wrong. If we're flying with the wind, or if we're flying with a tailwind, then that means that we are going in the direction of the wind and it's helping move us along, so we're going faster. Whereas if you fly against the wind or a headwind, you're going against the direction of the wind. It's going to slow you down. And then same thing with current. If you go upstream, it's much more difficult because you're going against the current. So the current's going to slow you down if you go upstream. And then if you go downstream, you can just kind of coast it and the water's going to push you along, so you would go faster. So on this particular problem, it says, flying with the wind, a plane went 183 kilometers per hour. So that might be something that you might want to highlight. Then we have flying into the same wind. So flying into the wind is different than flying with the wind. So this is going against it. The plane only went 141 kilometers per hour. Find the speed of the plane in still air and the speed of the wind. So that must be what we don't know. Oops. That clearly was an error. All right. So here we go. So what I don't know is, let S equal speed of plane in still air. And then we're going to let W equal speed of wind. All right, so let's use this first highlighted sentence. Flying with the wind, the plane went 183 kilometers per hour. So I don't know the speed of the plane in still hour, but flying with the wind is helping me. It's increasing my speed. And I don't know what that wind is, but they're going to act together. And that's going to give me a total speed of 183 kilometers per hour. Conversely, if I fly into the wind, it's going to slow me down because I'm going against the wind. So my speed is going to get slowed down by the wind, and I'm now flying 141 miles or kilometers per hour. So then at this point, I want you to stop the video, solve the system on your own, and then restart the video. So for this particular system, if you just add it together the way it is, the W's will automatically cancel, and you have 2S is equal to 324. Then we're going to divide by 2, and then we have S equals 162 kilometers per hour. And that seems reasonable. A negative number would not seem reasonable. You could have a decimal, but definitely not a negative. So then to find our wind, we're going to plug this value, 162, into the first equation for S plus W equals 183. And so to solve, I am going to subtract 162 from both sides. And I end up with W equaling 21 kilometers per hour, which sounds about right for a wind speed. So I've found what I need. So therefore, and I'm just going to rewrite the question as a statement. So therefore, the speed of the plane in still air was or is 162 kilometers per hour, and the speed of the wind is 21 kilometers per hour. So work on your homework. Word problems are tough, but the more word problems you do, the better you get at them. So get cracking, get those problems done. Text me if you have any questions.